Welcome back everyone. In the previous tutorial we saw how to import the dataset on which we will tune the network. In this episode we will see how to practically tune this network using a training step which will be based on SNN torch functionalities. The first step to do is to import the trainer from Spiker Plus, so the trainer component. We can then instantiate the trainer, and when instantiating it, we will need to provide the software description of the network as an input. After instantiating the trainer, we can then proceed with the train step in order to start the training of the network. And the train step requires to specify the train and test loader in order to use the two sets of data to tune the network and to evaluate the results, and a number of epochs, that is the number of epochs for which the training will be conducted. Let's start from a value of 1 so I can show you briefly what the output of the trainer is. If we run the code, we'll see that the trainer will print some informations about the training. In particular, together with the network that we specify, there is another set of parameters that we can select, and it will be initialized as a default. So you see the Adam as an optimizer, a loss function that is the cross-entropy loss, and the number of epochs that we specified, the batch size that we decided, and then it prints a recap about the input data, so specifying the number of batches which belong to the training set and the total number of samples which belong to the training set, same for the validation set. And then after one epoch it will print a recap of how much time it required to train the network for this epoch and the results about the accuracy. Let's now select a larger value for the number of epochs in order to make the network to converge to a better accuracy. With the selected amount of epochs, you can see that the network converges to a good 96-97% accuracy. Now, if we want to store the results of the training in order to speed up the next steps, we can ask Spiker Plus to store the trained network in form of a state dict. We can do this by specifying the store parameter within the train step. So if we run the training again, we will go through all the steps, and at the end we will see the exported state dict. If we now look at the trained directory, you will see the trained state dict containing all the trained parameters.